my champions, how are you all? Welcome to our platform Diksha Karnataka, where learning is fun. And why I say so is because so while doing a preparation for any aspirant of any particular competitive examination, okay, there's a lot of stress that comes with it, of course, because of syllabus that you have to cover, because of the planning that you had and it's not going well. So for all of that, okay, that can create a stress to your mind, okay. But on our platform we give you a proper strategy, proper framework which enables you to overcome that stress, okay. Won't you all agree with that? Yes. And so of course, before I move on to what we're going to do today, I want to take one doubt, the concern I see in your comments. Of course I read your comments, okay. So whenever I can, I try to give you full answers for all the questions that you're asking, okay. But because of there are a lot of questions, it's difficult to answer all of them in comment section. I'll try to do my best, but what you do know, please try to solve the same question. Of course I've solved the question in the session, right? So you can try to solve those questions again and again. Try to do at least 2 times, okay. And when you are doing that 2 times, so of course I'm telling you, you'll get it right. Even if you don't get, then of course put your concerns in the comment section, or you can come in the sessions and ask your doubts as well. That's what we are here for. We want to get all your doubts cleared, okay. Now let's talk about the session today. So session today is going to be a very important session for 2 reasons. Let's introduce the session first. We have ITF inverse trigonometric function part 1. We'll see the session planner, how I have planned the entire chapter. But right now, why did I say it's an important chapter or important session? Because again, the beginning of the first this is the first session of this chapter, okay. So we'll learn most of the concepts here only. So this is a small chapter. I will not take a lot of time to cover this. Maybe by the end of 2 sessions, entire concept part will be covered, okay. So this session becomes very important because I'm going to cover most of the topics here itself, okay. Now so let's see why it is important. The first thing is the questions coming, whether in your PU boards, whatever, like in your board syllabus or in your competitive examination syllabus, if it is coming from this chapter, will be very, very easy, straightforward, based upon domain and range. If you know the graphs, or if you know the properties of the ITF, that will be enough to solve the questions that is coming your way from this particular chapter. Now that is one thing. Why is it? Simple questions from the chapter directly itself in various examination, whether it is boards, whether it is any competitive examination, it will be very much direct. Secondly, so for all the chapters which is coming from calculus, whether it is AOD, continuity, differentiability, integrals, where you guys find it difficult, I know it's not difficult. Once I teach you guys, of course you will say that, sir, it is easy for us. But right now, if you have a concern that the chapters like integration are difficult to you, all those chapters of calculus has application of inverse trigonometric function in it, okay. So if you learn this properly, you'll be able to solve the questions there little bit easier than what you will do if you don't know the chapters well. Getting my point? So first of all, direct questions from this chapter, and second, the basis of this chapter will be there in the calculus unit. With that, can I start the session number 1? Let's see the planner now. So if you see the planner, I have divided this entire chapter into 4 sessions. Again, small chapters, no need to have more than that. Yes, you guys are asking me for more questions. So what I'm going to do, I'm going to keep some more questions practice in your part 2 of your chapter ITF, okay. But as we go in this entire Sankalp series, for the chapters which is requiring more questions to be solved, I'll solve that there itself. Don't worry, I'll keep a special session just for question practice. Works? Okay. So part 1 today will deal with inverse of a function. Okay, of course there will be introduction. We'll talk about what is ITF, how does it come from trigonometric function, the domain and range, and the graph. The graph is the most important part. If you know the graph well, so I will not only show you the graph, I'll draw the graph for you. How do we get these graphs? I'll do all of that, okay. Moving on to the part 2 session, the session number 2, you'll have properties of ITF. Session number 3 will be KCET PYQs, okay. We'll try to take last 10 years PYQs, and P4, the part 4 will be JEE Mains PYQs, okay. Again, we'll try to take last 2-3 years of PYQs in JEE Mains. As you know about the preparation, the sequence of the classes in Sankalp batch very well. First comes your concept sessions, next your KCET PYQs, and the last you have JEE Mains PYQ. This is for all the information you need about the planner of the chapter. Now, why are we doing all of that? Why are you here to learn from me, and why I'm here to teaching all of you? Because we want to create rankers in next year's batch, okay. This is a result that we had Not only this, we had more to more results. We can't show it in the one slide. That's why few of them I've taken over here from the previous year's batch of KCET. Just from YouTube, we produced results like for Prajwal, for Kiran, we had Diksha, Samiksha, Sachin, and so many more results and ranks for all of us. Okay, what is our goal? Our goal is very simple, that if you are preparing from us, if you are starting your journey with us and being consistent in the process, you should be the ranker next year. That's our goal. Okay, that's the goal. That's the task I'm giving to all of you. Your name, your photo, your rank should come over here. That is our goal. Okay, that's why we are working this much over here, working hard on this platform to make sure we are able to deliver the promise that we are making. Okay, next, moving on. So before starting the chapter itself, let's look at the insights. As I already explained it to you, most of the things, but quickly we'll go through that. Explore the concepts of domain and codomain and range. These things are important. Okay, dealing with the questions, of course. So we'll deal with the questions based upon domain, codomain, and range. Simple chapter. We don't have much over here, but yeah, these three things are very important. Highly important for all competitive examination. Frequent direct questions. This word is very important. Frequent direct questions. So whether you talk about JEE, whether you talked about, okay, of course JEE has more than one concept together. Like of course, let's say a question is framed on ITF, it'll have more than one chapters clubbed together. Not only for ITF, okay, but for questions like on your KCET, Comet K, for all these examinations, you will have direct questions coming your way. Okay. Direct questions coming away from this particular chapter, the concept which is involved in this chapter. Okay, now this is very, very important. The application in the calculus unit. Okay, whether it is integrals, differentiation, AOD, everywhere it will be there. Easy direct concept based problems in whether it is PU also. No, you can expect the question directly over here as well. Easy, word is very important. Easy and direct questions can be asked based on the concept which is there in the chapter. I hope this is clear, right? Chapter insights. Moving on, today's session, what are we going to do? So as I already told you, so we'll talk about a little bit introduction. Okay, so about inverse trigonometric function. Okay, next we have inverse of a function. When can we find the inverse of a function? All right, next we have domain and range of ITF. Then we'll have graph of ITF. Okay, and then last we'll solve some questions also. So let's start the session now. So if you see the introduction, we have learned that very well. What have we have learned, sir? All the trigonometric functions are periodic in nature. Right or not? We've learned that very well, right? All the trigonometric functions are periodic in nature. Of course, there are different periods, 0 to 2 pi, minus pi to pi, minus pi to pi by 2, like that we have. Okay, that's not a problem. But I'm telling you, that is very important, that they are periodic. The problem with the periodic function is they are not 1, 1. I'll show you. So if I have a function like this, okay, let's draw a sine only. So we have sine function. That's how we go, right? If you take this sine function, no, if I take this to be y equal to sine x curve, if you draw a straight line parallel to x-axis, how many intersections you get? Of course, more than one, sir. Of course, more than one, sir. Please check. We have more than one intersections. Right, we'll have on this side also, so we'll have more than one intersection, but that's not the case of one function. We know that very well. For a function to be invertible, because we're talking about inverse trigonometric function, inverse word is there. For a function to be invertible, there must be, the function has to be invertible with the help of 1, 1 and on 2, right? In this case, we can't say it is 1, 1 or on 2. 1, 1 or on 2. So what we do is, so how do we make the function to be invertible, sir? Inverse of trigonometric function, that's the statement, right? Inverse of, ITF means inverse of trigonometric functions. So we have to make the trigonometric functions invertible. As of now, we don't have that. So we have to make the trigonometric function, what is it, sir? The word is bijective. The word is bijective. What it means? It means 1, 1, excuse me, 1, 1 on 2. What is the word? 1, 1 on 2. We have to make the given trigonometric functions 1, 1 and on 2 together. When you have this condition, which is called as bijection, then only we can say the given trigonometric function is, what is it? Invertible. And how do we do that? By something called as truncating domain. Something called as truncating the domain. See this, how do we do it? So we, instead of taking the entire graph, no, we try to truncate it. Okay, so if I'll draw the graph again, and it makes, so before drawing it, let me just show you how we're gonna truncate it. Okay, so I'm gonna create a section over here like this. Where is this point? So this point is at minus pi by 2, and this point is at pi by 2. I'll erase the extra parts just to make sense for all of you. 1 second. So let me erase this red line. Okay, by mistake I did that. I'm going to draw the graph once again in the zone of pi by 2 to minus pi by 2. See how it looks like. So this part I'm talking about. Over here we know that it will be minus 1, so it will go like this and something like this. That's the graph, correct? I'll draw it again fair, don't worry. So if you see over here, after the truncation, so this lines are called as truncation that we have done to the domain, right? Instead of using the entire domain, what is the domain of sin x? The sin x domain is all real, right? So I'm taking, instead of taking the entire domain, I'm taking a truncated part, okay? That truncation is from where to where? Minus pi by 2 to pi by 2. That is my truncation. Okay, so if I have to draw that, only that much of the domain for sin x, the graph looks like this. Please check. The graph looks like this. Okay, this point is my domain minus pi by 2. Again, this is pi by 2. Now, if you draw any straight line over here parallel to x-axis, you get only one intersection there. Now the function has become 1, 1. Now the function has become 1, 1. So over here, originally the function sin x, cos x, all of this trigonometric function were not invertible. But by making one change, what change is that? Truncation of the domain. We got the function to be invertible case. Let's look at the inverse functions now. How do we do it? So inverse of a function. So we'll look at trigonometric function now. So the good thing about this is, first of all, the function has to be bijective. We already discussed that. The function fx has to be 1, 1 and onto, that is called as bijective. Then what happens is, you can write a function g, okay, from the domain. See here, the domain was x, the codomain was y. It becomes inverted, y and x, okay. What happens to over here is, gy becomes equals to x. Over here we had fx equals to y. The variable is interchanged over here. What it means is, it means that if I talk, let's say the function is onto, right? The function is onto. Function onto means that your codomain and range is equal. Onto functions means your codomain is equal to range. So if I'm writing this function f defined from x to y, this x represents the domain. Usually this y represents codomain actually, but in this case, since the function is onto, I can write this y as range. Will that be okay? Will that be okay? Since the function is onto, I can write the codomain as range. So y becomes range. So basically, check here for the function f, the codomain, the range was y and the domain was x, okay? Whereas in the case of the function g, which is inverse of the function f, this interchanges here. So your domain is, this is your domain, and your x becomes range. Can you see the difference now? Okay, so if I write this, I'll take one example and show it to you. If I write here the function y equal to sin x, what's the domain? What's the domain, sir? You'll say all real. Can they write all real? We can't take that, because then again it will become periodic function. We have to go back to bijective cases. So we have to write here minus pi by 2 to pi by 2, close interval. Close interval, okay? And how about range here? So range will be, for the trigonometric function y equal to sin x, the range will become minus 1 to 1. Minus 1 to 1. Alright? So if you are looking at the inverse of this, how you write that? Y equal to sine inverse of x. Sine inverse of x, that's your inverse trigonometric function, okay? In that, what I'm trying to say here is the domain becomes ulta, okay? So here the domain was this, but this value will become range, and this was range over here, minus 1 to 1, that becomes domain. So your domain will become minus 1 to 1, and your range will be simply minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. I hope this is simple and making sense to you. These things are interchanged here. Domain and range are interchanged in the case of inverse function. That of course makes sense to us. Okay, I hope this is clear. That was we had to understand in this particular slide. Let's move on now. Okay, have a look. So don't worry about the class notes, okay? The class notes, I hope you are already getting it right. All the class notes will be provided in the WhatsApp channel that we have. I hope you have joined it. If you're new to the channel, if you're watching this video for the first time, do one thing. The WhatsApp channel's link is given in the video's description. Go ahead, click on that. Join the WhatsApp channel. Don't worry about the privacy. It's not a group. We don't get your data. Just what we're gonna do over here, publish our content, and you can download it from there. Any information about the sessions, any update about the session will be given over there only. Okay, any live is scheduled. For example, let's say we are scheduling a live for practice session. So that will be informed in the WhatsApp channel itself. Okay, so all the future updates will be given in the WhatsApp channel. So make sure that you have joined that. It's very, very important. It's our only way to communicate to you. Okay, only way to give you some information that we want to give, and all the class PDFs will be given over there only. I hope you have already downloaded it. If you have not, you have to join the WhatsApp channel. Okay, let's move on now. All right, now domain and range of IETF. So the range of trigonometric functions becomes domain. I already explained you that. And restricted domain, this is what, dear? After truncation, right? This word is very important. After the truncation, after truncating the domain, for example, what I mean by that is, have a look. So we have the domain as all real, right? Before that, after applying the truncation on this, the domain became what, dear? The domain became this. So this part is called as, restricted domain. Restricted domain. This is called as restricted domain. I hope this makes sense to you. Okay. Of trigonometric function becomes range or principal value branch. Okay. So if nothing is given to you, you're gonna take the principal value branch, which is going to be this particular result. Okay. Understand one more thing, that so in the case of trigonometric function, okay, your input was something called as angles and your output was some values, right? Okay, some numbers, some values were the output. For example, tan 30, okay, 1 by root 3, sin 30, 0.5. Okay, so output was some values which doesn't have any unit to it, and for input we had angles in the case of trigonometric functions. But when we move on to IETF, understand it very clearly. Okay, your input will be the values and your output will always be angles. The result of or outcome of an inverse trigonometric function is always a angle. I hope this makes sense to you. It will always an angle. I know this is very silly things, very small things, but it matters when it, in the high pressure time of examination, these things helps you. So please remember, output is always a angle in the case of IETF. Make sense? Moving on. Next, so few notes to remember. Have a look. Whenever no branch of inverse trigonometric function is given, we mean the principal value branch. What I wrote there, minus pi by 2 to pi by 2. Again, it will be different for all the cases, all the functions. I'll show it to you one by one in the table. Don't worry. The value of the inverse trigonometric functions which lies in the range of principal value branch is called as principal value of inverse trigonometric function. Same thing. Okay. Principal value branch talks about the domain. This part here, this talks about the domain. Okay, and the principal value of the inverse function talks about your range. Okay, let's move on. Now the graphical part. This is very important. You have to all know how we are drawing the graph, what's the nature behind it, because it will be very, very useful in your calculus segment. When we talk about especially AODs, okay, application of different derivative or integrals, there the graphical part of inverse functions becomes very significant. Of course, all of you will agree once I start teaching you that. If you have already learned that, then you will know how important that is. Let's start right now. So I will not show you the graph itself. In this case, what is the graph of? This is a graph of inverse of, so written over here, right? You can see over here, y equal to sine inverse x, the graph is given for. So I will not just do that. I will draw the graph for you. So I have taken a blank slide, and of course, we'll talk about this nature. I've written over here all this nature we'll talk about: increasing function, odd function, max, minimum. We'll see that. Okay, so before I move on and do that, let me draw the graph for you. So from where the graph will come? The graph will come from sin x, right? I can draw the graph over here first. So graph of sin x, sir. Okay, the graph of sin x. Give me 1 second. I might take some time. The session might be easier but little lengthier because I want to do everything for you. But don't worry, when I do go to the question, it will become very faster, because if you learn this properly, if you learn the concept part a little bit with some giving some time properly, questions will become easier to solve and faster to solve also. So this is your x-axis, y-axis. I have to draw which curve first? Sin x curve. Where? In the entire domain? No, only the, what is it called as? Restricted domain. Only in the restricted domain. Okay, so let's draw that. So what we have over here, the graph looked like this. If you remember, this is the graph we had, right? This is the graph in the domain restriction. Domain restriction. Mass pi by 2, pi by 2. Domain restriction is provided. Okay, now what is the case? We are looking for inverse. So what happens in inverse? We take the mirror image about a line called as mirror image about which axis? Y equal to x line. Y equal to x line. Let's draw that. Okay, so it's right over here. Please check. Okay, when you draw that, you'll have the curve like this. You'll have the curve like this. Please check. That'll be a curve. Okay, I know it doesn't look very perfect right now, but if I draw it on the sides, so this is your curve. Have a look. Just look at this part. Okay, that's your curve. So mirror image about the yellow part, which is nothing but y equal to sin x. We're getting over here y equal to sin inverse of x. Okay, and same over here, this is your sin x curve and this is your sin inverse x curve. Sin inverse x curve. Okay, the purple part. It doesn't look very clear over here, but I have drawn it separately to make sense for all of you. Again, as I said, this will change your domain and range will change. So let's draw that as well. Let's draw the boundaries also. So this will become -1, of course, and this will become +1. Okay, and this will be minus pi by 2. Okay, and this will be plus pi by 2. Plus pi by 2. Same graph is over here. Please check. Minus pi by 2 to pi by 2, minus 1 to 1. That's your curve. Yes or no? Yes. Now the nature part. See the graph's nature. If you go from left to right across x-axis, if you're moving from here to here, what happened to the graph? It's increasing all the time. So it means the nature will be, first thing, increasing. First thing. Second, odd or even function, it's an odd function. Sin inverse of minus x is actually minus sin inverse of x. It's an odd function. It's a odd function. Next is what? Maximum minimum value. So the maximum value will be how much? Please check. Will it be 1, sir? No. When I say value, I mean the y value, right? Y value will be plus pi by 2. And what is the minimum value? Minus pi by 2. That's the minimum value. Okay, have a look. This is clear. So if I have to draw and write the domain, and over here I can say domain for this graph is -1 to 1, close intervals, and range is what, dear? Minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. I hope this is clear. So that's how you draw the graph of y equal to sin inverse of x from y equal to sin x, which is the graph of ITF from trigonometric function basically. And how do you draw it? By taking the mirror image about y equal to x line. This line is called what? This white line is called as y equal to x line. Y equal to x line. Okay, moving on. These two are clear, right? Okay. Next one. Next is cos inverse of x. We can draw this graph also. Let's see. So we'll see over here only. first draw the graph of y equal to cos x. So graph looks like this, if you remember. Okay, and yeah, right, yes. Correct. So we're gonna draw from 0 to pi. I'll be better. That is your domain truncation over here. So this was correct only. I'll just draw it more accurate. More accurate will be the right word. Okay. So this is your value at 0, which is 1. This is pi by 2, and this is pi with a value of -1. Okay. This is nothing but -1. Okay. As I said, you have to draw about the curve y equal to x, the mirror image. So let's draw that. This is your curve. Okay. So what happens is, you're going to take the mirror image of the part above this, which is this part over here below. So I'll draw it. It looks like this. Okay. This is the part over here. If I call it, let's say, if I call it to be part I, this is your I part. Okay, this is your I part, the mirror image. You can see that it is mirror image only. All right, I'm going to erase that I just to avoid confusions. Okay, and next is what, dear? The mirror image about of this other part we have. This other part. One second, this part I'm talking about. I'm going to take the mirror image of this. So it'll come like this, right? It'll come like this. Please check. Okay, so how will it come? I'll take the color again. So 1 second, excuse me. So I have to start from here only, and the graph will go like this, right? No. My mistake, dear, my mistake. It has to be bulging out, not bulging in. Okay, so bulging out only. Okay, so it'll be like this actually. Yeah. Now you can see, if I have to show you, just look at the green part. So this red part and this part doesn't look like the mirror image. This part I'm talking about. This part and this part looks like mirror image or not? Yes, it does. Okay. So basically, my final curve, if I have to draw final curve, have a look. It's somewhere like this. This red part and the green part. That's my final curve of ITF. Okay. This original curve was for cos x. This curve over here is for cos inverse x. Cos inverse x. Makes sense to you? So the points now, this was output is 0 angle, right? This is 0 only. This is pi by 2, and this is actually pi. This value is 1. Okay, and this value is -1. Okay, have a look. This curve represents y equal to cos inverse of x. Domain, if you have to decide, domain is coming out as, have a look, again, close intervals -1 to 1, and your range will be the angles, and for range we have 0 to pi. 0 to pi. Have a look. Range is 0 to pi and domain is -1 to 1. -1 to 1 is your domain. This is the x-axis and this is the y-axis, right? Okay. And the range is 0 to pi. This is the minimum value and this is the maximum value, pi. Works? Okay. Now, so the nature, if you have to talk about, the nature is again increasing, decreasing. Please check. So it's going to be decreasing function, right? So if you talk about nature, right? So nature, first one will be decreasing function. As you can see from the graph, if you move across x-axis, the value of y keeps coming down, okay? So decreasing function, so neither odd not even, okay? Neither odd nor even, okay? What I mean by that is, if you take cos inverse of minus x, it doesn't come out as the value minus cos inverse of x or plus cos inverse of x. This actually becomes pi minus cos inverse of x. Pi minus cos inverse of x. That's why we don't have any of the case. That's why we say neither or not neither odd or nor even. Okay, and what about minimum value? The minimum value is 0, max value is pi. Minimum value is 0, max value is pi. These two. This is the maximum and this is the minimum. Works? Please check. Clear? Okay, so I think the cos inverse part is clear now. Moving on. Okay, class notes you can get in the WhatsApp channel. Don't worry about that. Channel you'll get tan inverse of x. So again, if you draw the tan graph, let's draw it. So we'll draw the curve. This is the curve that we have for tan x. It is wrong. I'll draw again. So this is the curve that we have for tan x. Okay, and so this is going to be your values. Right now we have this as minus pi by 2 and this has pi by 2. This again goes to plus infinity and this goes to minus infinity. This is clear? Okay, good. Drawing about your image will be taken about this line, right? Okay, that's your curve. That's your image you're going to be taken about. This line is called as y equal to x line. Y equal to x line. Drawing the final curve. So image of this will come like this. Please check. Image of this will come like this, and image of this part, this blue part, will again come like this. If you have to draw the graph separately, let's just name it first. This is your tan inverse of x. This is your tan x. And this you already know, y equal to x, the inverse line. Okay, we are taking the mirror image. Final graph will look like this. Have a look. So your graph looks like this. And these are the boundary lines. Okay, this point is minus pi by 2. This point is pi by 2. How can I say that, sir? It was on the x-axis, right? Remember, minus pi by 2 over here and pi by 2 over here. This is pi by 2 only, right? This is minus pi by 2. It goes on the, this goes on the y-axis. So over here we have minus pi by 2 to pi by 2, the interchange of range and domain. And what about this? This again goes to minus infinity and this goes to plus infinity. So if you write the domain and range, domain becomes all real basically. How do you write that? Minus infinity to plus infinity. Open, open, and range will be minus pi by 2 to pi by 2, both open. Why open, sir? Because it can never reach minus pi by 2, can it? It can never reach minus pi by 2. I hope this is clear. Can it ever touch this line? It can never touch it, okay? Because it goes to infinity on that point. It's not a definite point. That's why we can't touch this. So both sides are open in either the case of domain and range. I hope this is clear. The graph is clear, right? So I've drawn the graph for sine inverse, cos inverse, and tan inverse. This is the properties now. The nature. The nature is very, very simple. First one, increasing function. Makes sense to you? If you move across x-axis from left to right, the graph value, the y value is increasing, right? So it's going to be increasing function. Increasing function. Second one, it's an odd function actually. If you take tan inverse of minus x, it becomes minus tan inverse of x, minus tan inverse of x. So we have odd function. Third, you know the values, right? Does not exist. Maximum value is not pi by 2, okay? And the minimum value is also not minus pi by 2. Does not exist, both the values. Because the upper band and lower band is not defined only, right? Will it ever touch minus pi by 2? It will never touch minus pi by 2 and it will never touch pi by 2 also. So we don't have maximum or minimum in the case of tan inverse x or tan inverse graph. Okay, works out. Moving on. This is clear, right? Great. Which curve is this? This is y equal to tan inverse of x. Tan inverse of x. Simple curves only. It's not like very difficult ones, but it has to be understood very, very well and in the simplified manner. Moving on. Okay. Now after drawing the curves of the three first ITF, I'll not draw the curve of the last three. I'll just show you the curves. Okay. And that'll be enough. So please check. So in this case, what is the domain, sir? Again, all real. This is the curve for cot inverse of x. We have domain as all real. Okay, the graph is decreasing in nature. The graph is decreasing in nature. It's neither odd and nor even. Second point is, again, I can write here, not odd, not even. Okay, neither case is true. And of course, maximum minimum doesn't exist because it's never touching this point or this point. Okay, so again, the domain will become 0 to pi. Sorry, the domain will become all real. Okay, and range will become 0 to pi but open intervals. Okay, so your domain that we have is all real. What it means is, okay, and your range is 0 to pi but both open here. It's not closed. Okay, they are both open. 0 to pi is open intervals. This is clear. Next one, cosecant inverse of x. Again, this is a, please check, decreasing function. If I go across x-axis, y drops, y value comes down, decreasing function. Okay, domain, if you see, what is the domain over here? Domain is very simply this infinity, right? Which infinity is that? Negative infinity to minus 1. Okay, here open, here closed, union 1 to positive infinity. 1 is there, then positive infinity. Open. Okay, 1 is closed and positive infinity. What about range? Range is from minus pi by 2 to pi by 2 except for 0. Please check. Range is what here? Minus pi by 2 to pi by 2, both closed except for 0. Except for 0. 0 is not part of the domain. Sorry, range. 0 will not part of the range. Okay, works out. Please check. All right. This is clear because it will never touch the x-axis. Yeah. So it will never be 0. Y will never be 0. So that's why we have, from the range, we have taken the 0 part out. Clear? Okay. This is your cosecant inverse graph. Nature is what here? Decreasing. Nature is decreasing and odd. Decreasing and odd. Decreasing and odd. Okay. Next one. The last one, second verse. You can see from here again, in this case you can write, so this is your homework. Okay, from the graph only you can tell me domain. I'll give you 2 homeworks today, simple ones only, but you can do it and let me know in the comment section. So domain you can tell me, range you can tell me, and nature. So first one you're going to tell me, I'll tell you the second one. It is not odd, not even also. Not odd, not even. Okay, not odd, not even. But you tell me the increasing decreasing part. You'll tell me the increasing decreasing part by looking at the curve. So your homework from this slide is, tell me the domain, range and nature, whether it is increasing or decreasing for which curve? Y equal to sec inverse. Y equal to sec inverse. Let's move on now. The curve is given. So I have done what is, I have taken all of this information and put it in one slide. Okay, check here for sine inverse of x. Domain is this. Already taught you that, and range is here. Okay, already given you over here, right? I've already given you all these values over here. So I'll just quickly, okay, move it out. But okay, fine. You can see from here the graph sec inverse also has the domain over here and range listed over here. My bad. Okay, now is the time to solve some questions. Again, I'll give you one more homework, and so total I've taken 5 questions today in this session, because as you know the pattern of the Sankalp batch, first we do the concept part, then we move on to question practice. Okay, so but even in the concept batch it's a maths class, so I don't want to just go and do the concept. I could have ended the session over here today, but I want to solve some questions also. So here comes your questions. This is your homework. This question is your homework. Why homework? I'll tell you very simply, because dear, I'm going to teach you tomorrow in the next session, basically not tomorrow, in the part 2 of this session, properties of ITF. There I'll teach you how the cot inverse of negative value works. But if somebody knows the answer, knows how to do around and go around and solve this, so I'll tell you what, I'll give you the property directly. So cot inverse of minus x actually is nothing but pi minus cot inverse of x. This property you can use, and we have to use one more property. This is the first use. Second property is quadrant rule. Quadrant rule means in which quadrant which values are positive or negative. I have taught you quadrant rule in my bridge course, right or not? Yes, I've taught you my quadrant rule, how to do, how to identify or which quadrant which ratios are positive or negative. I've taught you all of that. So you can use that quadrant rule. If it is utilized over here, I don't know whether it is useful in the question or not, but usually it is. And your cot inverse property, cot inverse of minus x is going to be pi minus cot inverse of x. Use these two formulas. If you can solve it, do solve this question and let me know the answer in the comment section. Okay, I'll solve the other 4, and if not, don't worry, I'll take the same question and discuss this question in the tomorrow session, basically the part 2 of the session also. So I'll come back and solve this question for sure in the next session. Okay, right now it's your homework. If you can do it, you will do it and let me know. Next, move on to question number 2. The domain of the function cos inverse of 2x minus 1. How do you solve it? So sir, we don't know about this. Forget about that. No, cos inverse of y you write. Cos inverse of y you write. Basically replacing the value of 2x minus 1 by the variable y. Can I do that? I can do that, so not a problem. But the range, so the domain part has to be taken in that format only, the y format. Please check. Do not take for x, take for y. Y domain will be, sir, we know that very well, minus 1 to 1. Right, domain of cos inverse minus 1 to 1. Basically it means is y lies between minus 1 to 1. Right? Because of the including brackets that we have, the square brackets, I have to write here equality also. So greater than equal to, y is greater than equal to, and 1 is greater than equal to y. Okay. Now instead of y, what was the value of y? Y was actually 2x minus 1. So simply put the value of y as 2x minus 1 and see the magic. Okay, 2x minus 1, 1. Move this 1 on both sides, because when you're solving the compound inequalities, no, you have to take the operations on both the sides, not only one side. Okay, or you can do what? You can do the individual solution of the inequalities like this. You can make the 2 boxes over here and solve them individually, your choices. We don't have to do that. It's simple over here. In this particular case, it's very simple. But if it is complicated, no, you can separate it in 2 different inequalities and then solve it. Okay, chali. Let's solve it over here. I get minus 1 already there. This minus 1 moves on this side, becomes plus 1. This is as it is the symbol 2x. Symbol as it is. Again, if we had already plus 1 over here, this goes on this side, becomes again plus 1. This is 0, 2x. 2 we have. Now I want the value of x, right? So I'm going to move this 2 on both sides. This 2 is a positive number. That's why there's no change in the inequality. Remember, very important. If it was a negative number, if we had minus 2 over here, then the inequality will reverse its nature. Then the inequality, less than inequality, will reverse to greater than inequality. But in this particular case, this 2 is positive. Okay, that's why no change. 0 by 2 less than x, 2 by 2. Okay, what I get from here, 0 by 2 is 0, x less than 1. It means simply my x value belongs to 0 closed, 1 closed. My answer is option A, done. Option A, done. Let's move on. Right, so previous one is done. Question number 2. Right, if you want to see once again, you can see it over here. Works for all of you. Let's begin with question number 3 now. Question 1 was given as homework. That is clear. Okay, value of cos of tan inverse of 3 by 4. A very difficult question? No sir, it's a very easy question. I'll tell you how. Tan inverse of any value will come out as angles. I told you it's very important. I can take this as some angle alpha. I can do that. I can do that. Please check. If I take alpha equals to tan inverse of 3 by 4. What is actually this written as? Cos alpha? Yes or no? So if I take this value as alpha, tan inverse of 3 by 4 I take as alpha, it means what is written over here is cos alpha. Right? Cos alpha. Okay. Now can I find tan alpha from here? Yes. Move tan inverse on this side. You get here tan alpha. So what you basically do over here, don't move, actually you take tan on both sides. You take tan on this side and tan on this side. It becomes tan of alpha, it becomes tan of tan inverse. This gets cancelled, okay? Inverse functions together gets cancelled. But you don't have to worry about that. You can think like this also. Tan inverse moves to on the left side. Tan inverse moves on the left side, becomes tan alpha, right? Inverse comes over here, becomes tan alpha. We have 3 by 4. Pythagoras theorem, sir. This is angle alpha. This is 4. How come, sir? Opposite by adjacent. That's the definition of tan theta or tan value, okay? Opposite by adjacent. We know that very well. There is a Pythagorean triplet of 3, 4, 5. So this is 3, this is 4. This means this has to be 5. If you are not sure, do it. Square of this is 9. Square of this is 16. Add them, you get 25. Whose root is going to be 5 only, right? 9 plus 4, square of 4, 16. Sum is 25. Root of that will become 5. So 3, 4, 5 is a Pythagorean triplet. If tan alpha is 3 by 4, what is cos alpha in this case? Please check. Cos alpha, right from here. Cos alpha is given by adjacent by hypotenuse. 4 by 5. So why cos alpha, sir? Because we are looking for cos alpha, sir. Answer is option A. Simple. Very simple. Answer is option A. Sir, cos of tan inverse we are looking for. It's okay. We have taken that as alpha. From alpha we got tan alpha. From tan alpha I use the Pythagorean triplet 3, 4, 5 to find cos alpha. And I'm looking for cos alpha only. No. Hence answer is option A, 4 by 5. Works or not? Very easy. Okay. Question number 4 now. Let's solve. If x plus 1 by x equals to 2, the principal value of sine inverse of x is what? Understand? Principal value means angle should come out. Okay. Okay. So let's solve it. X plus 1 by x equal to 2 is there. Simplifying it will do what? Basically I can take this as LCM x square plus 1 equal to 2. Right? X on this side becomes x square plus 1 equal to 2x. Right? Move this 2x on this side, we get x square plus 1 minus 2x equal to 0. What is this, sir? It's a trinomial. A square term is there, b square term is there, 2ab term is there. How, sir? X square plus 1 square minus 2 times of x into 1 equal to 0. Yes or no? X square is x square, 1 square is 1, 2 into x into 1 is 2x only, right? Okay. So we have a square, b square minus 2ab. It means answer is x minus 1 the whole square equal to 0. Solve it. We get x value as 1, sir. Value of x is 1. Very good. Very, very good. Value of x is 1. I'm looking for sine inverse of x. Sine inverse of x. Put x value as 1. Sine inverse of 1. How much is that? Pi by 2. How much is that? Pi by 2. Sine pi by 2 is 1. So sine inverse of 1 is pi by 2. Makes sense? Option is C. Option is C. Yeah. Fourth is done. Have a look. Question number 4 is done. Next, move on to question number 5. Question number 5. We have domain of the sine inverse of x, where denotes GIF is minus 1 to 2. Okay. Minus 1 to 2, minus 1 to 2. So one plate is closed, other is open. We'll see like that. Okay. So what is this called as? This represents GIF. GIF means greatest integer function. I have taught you that in the again bridge course. You have learned that, right? Yes. So how do you solve that? Think about it. If I had only, what I tell, replace this by a variable y. How can I do that, sir? I can do that. Not a problem. I can write y equal to GIF of x, and it's a simple substitution, right? But now the domain has to be written for y, not x, because y is the variable, right? What's the domain of this? Please check. Sir, y you just wrote minus 1 to 1. Minus 1 to 1 is the domain of sine inverse. Great. I'm looking for GIF now. I'm looking for GIF now. So I have to do what? Think about it. I have to use my brain to it. Okay. So if I write this as and I want to remove this GIF, I want only x to be written, I have to use my brain now. Think about it. So if I take a number line, minus 1 over here, 1 over here, okay? Think logically. If I write here, dear, if I take a value beyond this minus 1 point, I can take minus 1.5. Put it in the GIF, minus 1.5. What is the answer? Answer is minus 2. Is it acceptable? Is it acceptable? If I take x value as minus 1.5, I get the value of GIF of x as minus 1 by minus 2. It means sine inverse has to operate on minus 2. Is it possible? No, sir. Sine inverse is limited to minus 1. Okay? It means I cannot go beyond minus 1. It means all this region is out of the picture. Clear? I cannot go beyond minus 1. What about this side, sir? What about this side? It means I can take, sir, let's say point minus 0.8. Minus 0.8. Let's try that. Let's try that. Put it over here, minus 0.8. What is the answer going to be? Answer going to be minus 1. Is it acceptable to put it in the sine inverse? Yes, it is acceptable. Okay, we can put the minus 0.8 in the sine inverse. It's okay. It means this region is acceptable. This region is acceptable. This is all okay. This whole region is acceptable. Means minus 1, 2. Now where? Can I go till 1? Can I go till 1? Let's try that out. Put 1 in the GIF. Answer is what, dear? 1. Sir, acceptable, sir. Even 1 is acceptable. So minus 1 is acceptable. Minus 1 to 1 acceptable. Now what about after 1? Can I put 2, sir? Put 2 here. Can I put 2, sir? No. It will become 2 actually. Can I put sine inverse of 2? No. Sine inverse operates between minus 1 to 1. I can't go 2. But if I take a value less than 2, think about it. 1.999. What's the answer for this? It becomes 1. That's the property of GIF, right? The property of greatest integer function is that if you put a number, okay, the integral value of this over here, any number you put, the integral value of this will be your outcome. Okay, so answer is going to be 1. It means I can go all the way from minus 1 to 2 except for 2. 2 is not inclusive. I can go all the way. I'll erase all the extra information. Okay, so I can go all the way from minus 1 inclusive over here to 2 except for 2. Minus 1 except for 2. My answer will become minus 1 and 2 is there but open interval. Remove this equality, open interval. So my answer is now following. Please check. X belongs to minus 1 close and 2 open. Minus 1 close and 2 open. Option is B. Option is B. Have a look. Option is B. Clear? Clear, right? Option is B. Minus 1 inclusive, 2 open. I explained you how on using the number line also. I hope this is clear. Doubt you have, let me know. But before that, please try it once more. Okay? Try it once more. Alright. So with this, I can move on. Okay? Now last question of the day. We'll complete this question, and I told you I'm going to solve 5 questions. One, I've given you homework also, right? You're going to try that, and next class I'll solve that question number 1. 6th question we have, domain of fx. So whenever you have functions written like this, no? Function number 1, function number 2, function number 3. You take intersection of all the domains. Intersection of all the domains. Check here, domain of this. Write domains, na sir. Domain of this. Minus 1 to 1. Domain of this, all real. 10 verse, all real, okay? Second verse, this is a tricky one. Minus 1, open, closed, union, right? 1 to infinity. Intersection, think about it, number line. Minus 1 here, 1 here. First one suggests first function that take between this. This is the first function. Second one says take all. Second one says take all. Third one says, okay, so between these two we can take only this, right? Intersection of the first and second is basically first one only, okay? Because second one says all, first one says only mass 1 to 1, but third one, the weird one, check. It says take all of this, take this, nothing here, take this and take all of this. It means I can't take between the values. Then what is the intersection possible only then? We have only minus 1 and 1 as possible intersection. Minus 1 and 1. Means if you take intersection of all the three, domain of 1 intersection with domain of 2 intersection with domain of 3 means third function. What's the answer coming as? Only minus 1 and 1. What bracket are you going to write? Curly bracket or middle brackets. Because we're talking about elemental value, individual value. Answer is basically minus 1 and 1, not minus 1 to 1. Not minus 1 to 1, only minus 1 and 1. Minus 1 and 1. Answer is option B. Please check. Okay, answer is option B. I hope this made sense to you. Okay, no doubts, no concerns, right? Because this says minus 1 to 1, right? Only that. Second one says all real. Intersection of those two. Okay, minus 1 to 1. This says all real, but this has only minus 1 to 1. Fine, then the second function settled for minus 1 to 1. Not a problem. But the third one says not minus 1 to 1, only minus 1 and 1 and the other part. Then we have to take the intersection over here again and we end up with only minus 1 and 1. Minus 1 and 1. Makes sense to you? Please check. Okay. Now this is clear. What did I say? You have to join the WhatsApp channel to download your class notes. PDF will be given there, okay? So join the WhatsApp channel, get the class notes, revise all of it and solve all these questions again. Then only get to have the confidence that, okay, you've done something. That's the complete process, okay? And again, if you have doubt, ask that as well. That's the complete process of the preparation. If you're looking to be one of them, right? We had a function, we had an event over here where we couldn't invite all of them because a lot of students were out of Karnataka, out of Bangalore. So we had to, whatever we were able to manage. You can see we all had a fun time over here, okay? Ashwarya ma'am, Jasmine ma'am, I was here. Soumik sir and all the students, we took one frame, one picture, okay, and we enjoyed our time. So you have to be one of them. How do you do that? By being focused, by doing all of the questions, by learning from all the concepts and asking your doubt. That's a complete cycle. Watching the video, downloading the PDFs, revising all of that, doing all the questions, and your doubts should be cleared. Then the cycle is complete and then you move on to the next session. Okay, when you do all of that, you will be one of the toppers, one of the rankers next year. This works out for, I hope this works out for all of you. Any concerns, any doubts you have, you're gonna ask me, okay, in the comment section. And if you're new to the channel, what you're gonna do, make a subscription of the channel. Subscribe the channel. It's for free. All the content available on the platform is for free. Don't worry about that. Okay, it just takes, just to give us motivation, just to make sure that we are doing something over there. Just give us this subscription. And very important for all of you, turn on the notification, because it's not some other weird type of content. These are educational content. You can't miss it on time. If you miss 5-6 classes, there'll be a lot of backlogs. Okay, so please make sure that you have turned the notification bell on. The icon should be turned on so that you're getting all the important updates and videos on time to you. Okay, with this I can end the session today. I hope you had fun. Any query, any concerns you have, you're gonna let us know in the comment section. You know that I replied to your concerns, right? So with this I can end the session today. Take care of yourself, keep working hard, keep smiling. I'll see you again very soon. Till then, take care. Bye-bye.